I'm assuming that you know how to use half AB sine C over 2 to find the area of a triangle. But I'm going to show you a couple of situations where trying to use the formula directly does not work. But then I'll show you how you can make use of the sine rule to get around those problems. By the way, if you don't know why the formula finds the area of a triangle, check out my video giving a detailed explanation. It's linked in the description. Now here's an example of what you might typically be asked to do. Find the area of this triangle. The formula half AB sine C works for this. The letters A and B represent two edges where you're given the value, and the letter C represents the value of the angle formed by those two edges. If, as in this example, the given edges are the ones that have the length of 9 and 7, then in order for the formula to work, C would have to be the angle formed by those edges. And indeed, you can see that the angle with the given value is the angle that is formed by the edges whose values are given. So C equals 70, and therefore these three values can be plugged into the equation, and that would give you the area of the triangle. Now in this setup, the angle that the two edges form isn't given a value, but we need the sine of this angle in order for half AB sine C to work. So the formula cannot help us here. This is where the sine rule becomes useful. And a reminder of what the sine rule actually explains: for each angle in the triangle, sine of the angle over the length of the opposite edge gives the same result. So in our example, dividing the sine of 70 by 9, the opposite edge, would give the same result as dividing the unknown angle by 7. The top angle is currently unknown, but if we plug the other three values into the equation for the sine rule and then use algebraic manipulation to get the sine of this unknown angle, we can use the inverse sine function to get the angle, and once we've figured out this second angle, we'll be able to work out the third angle. Let's give the unknown angle a temporary value of x. Now we have two given angles and their respective opposite edges. I'll use the sine A and sine B parts of the equation. So let's assign the variables in the sine rule equation with the values from the triangle. We'll give the angle A the value x. Lowercase a has to be the opposite edge, which is 7. Then the angle B will be 70 degrees. And the lowercase b has to be the opposite edge, which is 9. So sine of a over small a is really sine of, well, a equals x, and that will be over 7. And that will be sine b over small b. Well, b is 70, so that's sine of 70, and small b is 9, so that's over 9. And if we want sine x, we have to multiply both sides by 7, and the 7's on the left hand side cancel, and we get that sine x equals 7 times sine of 70 divided by 9. And if you run these numbers through your calculator, you will get that sine x equals 0.7308720. And if you want the value of the angle x, you would do arc sine or inverse sine of this number. And using the calculator, we get that x equals 46.95955, which means that now we have the value of two angles in the triangle. And so we can use them to figure out the third angle. For the sake of simplicity, I'm going to round the x up to 47 degrees. To get the missing angle, we simply subtract the sum of these two angles from 180, 70 plus x, which is 47. Add those two together and you get 117. So the missing angle is 180 degrees minus 117 degrees, and that equals 63 degrees. Our missing angle is 63 degrees. And now we have the value of the angle, which is formed by the edges with given lengths. And so now we can use half AB times sine of C in order to find the area. So I'm not going to do the calculation. I'm going to leave that for you to do if you want to. The main point was to show you how to get from a tricky situation to where you can use the formula for the area. Let's try one more quick example that's not so straightforward. Because we only have the value of one edge, that means that we can't use half AB sine C to find the area. What we do have is the value of one angle and the value of the edge that's opposite to it. Now if we had the bottom left angle, we would be able to manipulate the equations in the sine rule to get the right edge. And that would mean we had two edges where we know their length, and they would form this angle. And we would have the value of this angle, so we could use half AB sine C. The bottom left angle is easy to figure out because all we have to do is subtract the sum of the two angles we already know from 180. The sum of the two angles is 30 plus 55, and we know that to be 85 degrees. And so the value of the missing angle is 180 degrees minus 85, which equals 95. So the value of this angle is 95. Now let's hide the formula for the area and bring the sine rule up. We can label the unknown edge with an X. And now let's assign values to these variables in the sine rule. We'll give A the angle 30 and the edge opposite to A, which is small a, equals 7. Large B will be the angle 95. And small b is the edge X that we need to figure out. Now we can write the equation. So sine of A, well, A is 30 over small a, which is 7, is equal to sine of B, and B equals 95 over small b, which is X. We don't know that yet. If we multiply both sides by X, then the X's on the right hand side cancel. And if we divide both sides by sine of 30 over 7, it gets cancelled on the left hand side, and we get the inverse of the fraction on the right hand side. So that's sine, well, that's 7 over sine 30. And that leaves us that X equals 7 times sine of 95 over 30. And if you run that through your calculator, it'll give you that X equals this extremely long decimal. It's 13.946, etc. I'm going to round that up to 14, and now we have the value of two edges. Those edges form an angle, and we have the value of that angle. So we can use half AB sine C to find the area of the triangle. Assuming you know how to use the formula, you have the three values. I'm leaving you to calculate them if you wish to. Main point is you've seen how to get out of the tricky situation to the point where you can use the formula to find the area of the triangle. So that's it for now. Thank you for watching.